Hi, this is Ms. Wiles, and we're going to be talking about the distributive property in this lesson. We're going to first start out with a little warm-up, and then we'll go into some new vocabulary and into some examples after we discuss the key concept of the distributive property. Take a look at this problem. Pause the video on each problem and come up with your answer, and then we'll come back and give the correct answer and a short discussion. The answer to this question is A. You should have chosen the multiplicative property of 0 because you should have noticed that in this particular equation we are multiplying a number by 0 and the answer is 0. What property is demonstrated in the equation shown here? 7 plus, parentheses 11 minus 5, equals 7 plus 6. This property is simply substitution because we are substituting 6 for the quantity 11 minus 5. It is not the associative property because we have not just rearranged the parentheses. It is not the multiplicative inverse nor the commutative property. Remember that the commutative property just changes the order of numbers in addition, and multiplicative inverse is like 2 times 1/2 equals 1. Let's go on to number 3. Evaluate this expression without using a calculator. When you evaluate this expression without using a calculator, first you see that you have the multiplicative inverse, 4 times 1/4. Well, 4 times 1/4 equals 1. And then you notice in these parentheses you have 4 squared, which you should be able to say 4 times 4 is 16. Well, 16 minus 16 is 0. So 1 plus 0 is 1. Number 4. Name the addition property shown by this equation. You should have chosen the associative property because the parentheses have been rearranged and the numbers on each side of the equation have been kept in the same order. Remember that you are pausing before I reveal the question, after I've read the question, so that you can come up with your own answer. In this lesson, we'll be interpreting parts of expressions such as terms, factors, and coefficients. These are vocabulary words that you should know in any math class. You'll use the structure of an expression to identify ways to rewrite it. In the past, we have explored the associative and commutative properties. Now we're going to use the distributive property to evaluate expressions, and use the distributive property to simplify expressions. Your new vocabulary is like terms. Those are terms in an expression that are alike. For example, a number is like other numbers. For example, 3, 7, -14. Those are all like terms because they're all numerical. Other like terms might be 4x, 18x, 0.25x, because they are all involving the variable x. Simplest form. Simplest form is when you've done everything that you can to an expression to simplify it, to combine all the like terms, and to do all mathematical operations that are possible for you to do. A coefficient is a numerical value that comes before a variable. In the term 4x, the coefficient is 4 because it is showing that you have 4 x's, and that is a coefficient. Our key concept in this lesson is the distributive property. In symbols, we say that for any numbers at all, 3 different numbers, we just call them A, B, and C, that A times B plus C equals A times B plus A times C, where you have distributed the A across the parentheses and multiplied the A times the B, and then add, distributing again, the A times the C. And it doesn't matter if the A comes after the parentheses, you're doing the same thing. A times B plus A times C. And it works for subtraction too. When you see key concepts like this given in symbols, that is just to show you that it will work for any numerical values. Here are 2 examples. 3 times 2 plus 5 is equal to 3 times 2, 3 times 2, plus 3 times 5, which is 6 plus 15, following the order of operations and multiplying first, and that's 21. We're showing on the left-hand side and the right-hand side, as each side is simplified, 3 times 7 is also 21, that numerically you can do this either way. We'll progress to something more difficult where you have different terms where they're not all numerical like this. But the concept, the key concept, remains the same. And here's another example with subtraction, that 4 times 9 minus 4 times 7 is the same as saying 4 times 9 minus 7. And you'll get the same answer. 4 times 2 is 8, or 36 minus 28 is 8. Our first example is a word problem, and most of the time you'll see things in word problems, so it's good to practice this. Julio walks 5 days a week. He walks at a fast rate for 7 minutes and cools down for 2 minutes. Use the distributive property to write and evaluate an expression that determines the total number of minutes Julio walks. Now, in answering this question, you can use any kind of strategy that you have, but if you have to use the distributive property to write and evaluate an expression, then there's a particular way to do that. First, you need to understand that you're looking for the total number of minutes that Julio walks in a week. Next, you would make a plan. You would understand what's happening here, that Julio is walking for 5 days for 7 plus 2 minutes a day. He's going to walk at a fast rate for 7 minutes, and he's going to cool down for 2 minutes. Now, cooling down does not mean that he's laying down. It means that he's walking slowly. When you write an expression that shows the product of the number of days that Julio walks and the sum of the number of minutes he walks at each rate, that's going to look like this. For 5 days, he's going to walk 7 minutes at a fast rate and 2 minutes at a slow rate. And this is what that would look like with the distributive property. Certainly you could find that answer by making a list of all the 7s and all the 2s that he's going to walk, but this is the algebraic method of using the distributive property to demonstrate that. Then 35 plus 10, or rather let's back up a minute. 5 times 7 is 35. 5 times 2 is 10, for a total of 45. Julio walks 45 minutes every week. The total number of days he walks is 5 days, and he walks 9 minutes per day. Multiply 5 by 9 to get 45. Therefore, he walks 45 minutes per week. Understanding how the distributive property works when you have nothing but numerical values will help you when you get to the point where you have variables, which we're going to get there very quickly. Check your progress by pausing the video now and working out this problem. Welcome back. After reading this problem, you should have chosen C. In C, you see that Suzanne is walking to school and home from school 5 days each week. She walks to school in 15 minutes and walks home in 10 minutes. Rewriting 5 times 15 plus 10 using the distributive property is 5 times 15 plus 5 times 10 for a total of 125 minutes. You can use the distributive property to rewrite multiplication to make it easier. In this problem, we have 12 times 82. You can use the distributive property to split that 12 up and make it 10 plus 2. You're thinking, oh, 12 is 10 plus 2, so you can split it up. And you still have 82. Now you do 10 times 82, which is much easier. And 2 times 82, which is also easier. 10 times 82 is 820. 2 times 82 is 164. And you can add those together quite quickly. And 8 and 1 is 9. 2 and 6 is 8. 0 and 4 for a total of 984. And of course, your answer is 984. By the way, we have to do math in math class. You won't always have your calculator. In fact, in Math 1, there's a large portion of your testing that will be done without a calculator. Therefore, you must work on your inactive calculator skills and continue to recall how to add, subtract, multiply, and divide using numbers, and whether they're fractions, whole numbers, decimals, whatever they are. Check your progress here. Use the distributive property to rewrite 6 times 54 and then evaluate. Pause here while you work that out. You should have chosen C. 6 times 50 plus 4 makes this problem easier to solve. And it's 324 because 6 times 50 is 300. 6 times 4 is 24. Add those together for a quick 324 instead of writing all this out. Notice 6 times 50, 300. 6 times 4, 24. Add them together for 324. Now we're going to get into using variables. 12 times y plus 3 using the distributive property and then simplify. 12 times y plus 3 equals 12 times y because we're distributing that 12 across the parentheses plus 12 times 3. 12 times y is rewritten algebraically as 12y, and 12 times 3 is 36. Your answer, not sure why it makes me go through all that again, is 12y plus 36. And that's your final answer. These terms that you see here, 12y is a term and 36 is a term. They are not alike. Therefore, they cannot be combined or simplified any further. You can use the distributive property no matter how many terms you have inside the parentheses. You hear my phone there? So no matter how many terms you have here, you still use the key concept of the distributive property and then always simplify. 4 distributes across the parentheses times y squared, 4 times 8y, and 4 times 2. All of these plus because of the pluses here. And your answer is 4y squared plus 32y plus 8. Next, check your progress and simplify this expression. You should have chosen B. 6 times x is 6x. 6 times minus 4 is minus 24. Pause here and simplify this expression. Properly using the distributive property, you should have chosen C. 3 times x cubed is 3x cubed. 3 times 2x squared is plus 6x squared. 3 times minus 5x is minus 15x. And 3 times plus 7 is plus 21. Combining like terms. Combining like terms, when we notice that we have terms that are the same, and by like terms, they have to be completely and totally the same. And by the same, as I explained when we were talking about the new vocabulary, they're either just numbers or the exact same variable exponent combination. So 17a and 21a are like terms because they're both a's. And you can simplify that by combining and saying that, oh, I have 17 a's and I have 21 a's. Therefore, I have 38 a's. And that is your final answer there for that problem. To simplify this expression, you have 12b squared minus 8b squared plus 6b. There are 2 like terms here and 1 unlike term here. The like terms are the b squareds. B squares are alike. The b is not like the b squares because it doesn't have the same exponent. Therefore, for the b squares, I can have 12 minus 8b squared, but the 6b stays all by its little lonesome for a simplified answer of 4b squared plus 6b. Check your progress by simplifying 14x minus 9x. Noticing that the terms are alike, you should have chosen D, 5x. You have 14 x's and you're subtracting 9 x's for an answer of 5x. Use your knowledge to simplify this expression. Noticing that the n squared is different from the n that you have in these terms, you should have chosen 6n squared because it is different, and 15n for the 7n plus 8n. We are going to move into writing and simplifying expressions, but I'm going to save that for part 2, and that's really all I have to say about that right now, because we're getting to about 20 minutes, and I want you to take about a 5-minute break.